Welcome back to part 2 of this fundamental math for solar applications class. We're going to talk about decimals and percentages. So if we have a decimal and we want to convert it to a percent, we have to move the decimal point 2 places to the right. Let's look at an example. Here we have the number 1. We want to convert that to a decimal. We move the decimal point 2 places to the right and we get 100%. So 1 converted to a percentage is 100% because a percent is just a fraction of 1. 1 is a whole, so that is 100%. Look at another one, 0.85. Move that 2 places to the right and it becomes 85%. Here's a bunch more examples. 0.23 converts to 23%. 0.02 converts to 2%. Now this is where things get a little interesting when we add a bunch of zeros. So 0.0034 converts to 0.34%. We just move the decimal places 2 points to the right. Negative 0.0029, moving the decimal 2 places to the right, becomes negative 0.29%. 1.25, move the decimal 2 places to the right, becomes 125%. So all we need to know when converting a decimal to a percentage is that we just move the decimal 2 places to the right. Doesn't matter where it is, we just move it over to the right. And basically what we're doing is we are taking that decimal and multiplying it by 100%. So here the example at the bottom, 0.85 multiplied by 100% equals 85%. It's pretty straightforward once you get used to it. It just gets a little tricky when you add those extra zeros in for the fractions of a percent, which we see quite often in solar when we are calculating the voltage of a module using the temperature coefficients. The temperature coefficients are usually given in a decimal percent, so like the 0.34%, and then we have to convert it to a decimal to do the multiplication. Let's look at how to convert a percent to a decimal. In this case, we're just moving the decimal points 2 places to the left. Percent means per 100. So if we have 100%, move that decimal 2 places to the left and we get 1. If we have 18%, move the decimal place 2 places to the left and get 0.18, and so forth. So with 5%, we're still moving the decimal 2 places to the left, so we need to add a 0. 5% converted to a decimal becomes 0.05. Same thing for this example for 0.27%. This is a very common temperature coefficient of open circuit voltage. We just move that 2 places to the left and it becomes 0.0027. Negative 0.48%, that would be a temperature coefficient of maximum power. That would be a negative 0.0048%. Could be a temperature coefficient of maximum power. We can't do a calculation and get a voltage number without converting that percent to a decimal at some place. And it's important to know where that decimal is going to be and not get confused by adding those extra zeros. This last one, if we have 120%, convert that to a decimal, just move that 2 places to the left and it becomes 1.2 or 1.20. So it's pretty straightforward, and really what we're doing here is we're dividing the percentage by 100, and that's going to cancel out the 2 percentage symbols and we will get the decimal equivalent. So again, if we want to find a percent of a number, first we have to convert the percentage to a decimal. Then we multiply the decimal by the number. So here's an example. If we have an inverter that is 95% efficient and we want to figure out what the approximate output of that inverter will be if we have a specific size PV array operating at standard test conditions. So what we're going to do is we're going to divide the 95% by 100, because we can't multiply it by a percentage because we're not looking for a percentage, we're looking for what the output is. So we divide that 95% by 100% and get 0.95, and then we can multiply that 0.95 by our array size, 5,300 watts, and we can get an output of 5,035 watts. Now of course There's a bunch of things that we're not factoring in here in this specific equation. We're not considering any temperature variations outside standard test conditions. We're not assuming that the irradiance or the intensity of the sunlight is something different than standard test conditions. So this would have to be at standard test conditions. And we're not factoring in other things like shading and module mismatch and soiling of the modules and voltage drop. There's a whole bunch of other factors that go into this calculation if we wanted to be really accurate, but we're just using this as an example. So we have to convert that percentage to a decimal in order to get the number that we want. It's really important. We'll see this again when we do our voltage calculations. This applies in all kinds of different situations where we need to convert that percentage to a decimal in order to figure out what portion we're going to get of something. Okay, that's the end of part 2, decimals and percentages. In part 3, we're going to talk about how to calculate areas when we're looking at roofs or open space to put our array. So join me for that part when you're ready. Thank you very much.